Welcome to Review Recording 1A-B-C to accompany instructional recordings 1A, 1B, 1C for Unit 2, Chapter 2 of Trigonometry in Mathematics 2200. We'll do some examples about working with angles in standard position and using the relationship between an angle of rotation and its reference angle. Example 1. Which best represents an angle of 275 degrees in standard position? That term standard position is important because the initial arm needs to be on the positive x-axis. That rules out A and B because the initial arms are not on the positive x-axis. This one's on the negative x-axis, this one's on the y-axis. So it's either C or D. Let's put in our benchmark angles. 0 degrees is there, 90 degrees up here, 180 here. 270 is down here, and then we're back to 360. Well, 275 is obviously closer to 270 than it is to the 360 line. So our answer must be C. In example 2, we're given an angle of rotation of 91 degrees in standard position, and we have to determine which of the following four angles has the same reference angle. 91 degrees, that would put us in quadrant number 2, just past the 90 line. I've got to exaggerate this a little bit because that's definitely not 91. It's actually smaller and tighter to the 90 line. But for the purposes of illustration, this will do. So 91 would bring us right to there. It's 1 degree, of course, between the y-axis and the terminal arm, but that's not our reference angle. Our reference angle is always to the x-axis. And our angle theta is equal to 180. Subtract the reference angle. Our angle theta in this case is 91. So we have 91 degrees equals 180 minus whatever that reference angle is. Well, that needs to be 89 degrees in order to get a true equation there. Now let's see, out of the options we have here, 1 degree would be in quadrant 1. It's equal to its own reference angle, so A is not correct. 181 degrees, that would be in quadrant 3. But there would only be 1 degree between the x-axis and the terminal arm. So the reference angle would be 1 degree. So that's not correct. 359 would be in quadrant 4. And there would only be 1 degree between the terminal arm and the x-axis. So that one's not correct. Let's check on 269. 269 is pretty close to the 270 line. So we're going to be in quadrant number 3, and in that angle, remember our angle theta in that quadrant is 180 plus the reference angle. So we've got 269 equals 180 plus the reference. That means our reference angle, therefore, must indeed be 89 degrees. So our answer in this problem is C. For our last example, an angle of rotation, theta in standard position, has measures such that theta is between 180 degrees and 270. 180 degrees less than theta, less than 270. That means theta is between those two values. That means we're going to be working in quadrant number 3. The reference angle is 221, so what is the measure of theta? So we've got to work in quadrant 3. The reference, we're told, is 21 degrees. We're looking for theta, which rotates in standard position to that terminal arm. And for that quadrant, our angle theta is equal to 180 plus the reference. So that's 180 plus 21 degrees which is 201 degrees. Answer is A. To conclude, we can use benchmark angles of 0, 90, 180, 270, and 360 degrees because they are useful for determining the quadrant and approximate position of terminal arms for angles of rotation in standard position. And the reference angle is the angle between the terminal arm and the closest benchmark angle that lies on the x-axis. And the terminal arm of an angle theta in standard position can be reflected in the x-axis or the y-axis to obtain another angle having the same reference angle. That last point is an important one to revisit. For example 3, we could have approached it by doing a series of reflections, first across the y-axis, then down across the x-axis. We knew we had to work in quadrant 3 anyway, so by doing the reflections, we get to the proper location, and then the actual angle theta is equal to 180 plus the reference, or 180 plus 21 once again. And I'll mark that in. So you can approach these problems by doing the reflection or just by putting the terminal arm where it belongs and putting in the reference.